Welcome to The Explainer. We're about to jump into a story that's been unfolding for 200 years in the world of mathematics. It's all about a problem that everyone, and I mean everyone, thought was impossible to solve until maybe now. So, picture this. For 200 years, there's been this mathematical problem, this type of equation, that was considered completely impossible to solve. At least, not exactly. It was like a rule set in stone. But what if that rule was never really a dead end? What if someone just found a way around it? All right, so we're talking about a 200-year-old dead end. Before we can really appreciate what might be a massive breakthrough, we've got to understand the wall that mathematicians ran into all those years ago. So look at this timeline. It really hits home just how long this one idea has dominated the field. We're talking from 1824 all the way to 2023. That's 2 centuries, where a single theorem basically told everyone, nope, you can't go any further. For generations, the best mathematicians could do is kind of fudge it. They had to rely on approximations, getting close enough to the answer, because they were taught that a perfect, clean solution was just not possible. Okay, so this is the Abel-Ruffini theorem, the big roadblock. And the most important part, the real kicker, is that phrase, in radicals. What does that even mean? Well, think of it like this. Your mathematical toolkit has some basic tools, right? Addition, subtraction, multiplication, division, and taking roots, like a square root or a cube root. Abel's theorem basically proved that if you have a really complicated equation, anything of degree 5 or higher, that basic toolkit just isn't going to cut it. You can't get an exact answer. It's like trying to perform brain surgery with a butter knife. The theorem essentially slammed a big do not enter sign on that entire path. So that door was shut for 200 years. But what if there was another door? What if someone just found it? And here's the really clever part. The source says this new way forward isn't about proving Abel wrong. It's not a contradiction. It's about transcendence, which sounds a little out there, I know, but what it means is this new method just sidesteps the problem entirely. It doesn't break the old rules. It just plays on a completely different field where those rules don't apply. So this is Ezouidi's theorem, and this is the new toolkit. Now, don't worry about the crazy-looking terms here. The big idea is that instead of those basic radical tools, it uses much more powerful, sophisticated methods. It's like upgrading from a hand drill to a state-of-the-art laser cutter. And the claim is that with these new tools, you can get a perfect, exact, symbolic solution for any polynomial equation, no matter how high the degree. That is a massive claim, flying in the face of 2 centuries of accepted wisdom. So let's put them side by side, the old way versus the new way. This table just lays it all out so clearly. The old way? It hits a wall at degree 5. The new theorem? It says bring it on. Any degree, doesn't matter. The old way gives you approximations with little rounding errors. The new way claims to give you exact, symbolic answers. We're talking 0 error, perfect precision. I mean, you can see how this would be a complete game changer if it holds up. These are some seriously bold claims. All right, that's the theory. It sounds amazing, right? But does it actually work? Let's look at how the source puts this thing to the test with a supposedly unsolvable problem. So the process is laid out in these 4 steps. Think of it like a recipe, or maybe a machine. You start with your incredibly complex, messy problem. You feed it into this special formula, the engine of the theorem. The engine does its thing, calculating all the pieces recursively. And then, at the end, it spits out the exact clean answer. And here is the beast. The problem they're tackling is a 16th degree polynomial. I mean, look at that thing. It goes on and on. Using the classical methods, a computer would just start guessing. It would churn and churn, getting closer and closer, but it would always just be an approximation. You'd never get the perfect answer. And this is the engine. Now, deep breaths. You do not need to understand this formula. I don't understand this formula. The point is, this is the core mechanism. It's the set of instructions that takes that chaotic 16th degree polynomial and systematically, piece by piece, breaks it down into something manageable. It's the magic black box that turns chaos into order. So what comes out the other side? After all that complexity, after running it through that engine, you get this. Just zeros. 16 exact symbolic roots. And in this example, every single one of them is precisely 0. No decimals, no rounding, no it's about 0. It is exactly 0. It's taking that tangled mess of an equation and revealing this incredibly simple, elegant solution hidden inside. It's kind of beautiful, right? Okay, so let's zoom out. If this thing is legit, if it really works, What does that mean? What are the ripple effects for the world of math?
Well, according to the author, the implications are huge. First, it blows past Abel's 200-year-old limitation. Second, it could make all that numerical guesswork, all that approximation, totally obsolete for these kinds of problems. Why guess when you can know for sure? And get this, it even claims to do better than modern AIs, which often still rely on those same approximation techniques.
And this final quote from the source really says it all. Quote, "The door that Abel once closed has been reopened permanently." That's not just saying we found a new trick. That's saying the game has fundamentally changed. So that's where we're left. Now, to be clear, this is a very new claim, and you can bet the entire mathematical world is going to be putting it under a microscope. But it makes you wonder, doesn't it? Has the book on what's unsolvable just been completely rewritten? Is a chapter we all thought was finished for 200 years about to get a brand new ending?